Hello guys, welcome to the video on queues as a data structure. So queues are very similar to stacks. If you know stacks well, it'll be really easy for you to understand queues. Once you understand queues, you will see real-world examples of them everywhere. Beginning with the definition here, according to Wikipedia, in computer science, a queue is a collection of entities that are maintained in a sequence and can be modified by the addition of entities at one end of the sequence and the removal of entities from the other end of the sequence. A queue is basically a collection of elements, just like a stack. If you remember in stacks, there is only one end at which both the insertion and deletion, or push and pop of the elements takes place. But in queues, we have two separate ends performing the two separate operations. The front end through which we remove the elements, and the rear end through which we insert the elements. Essentially, a queue is a FIFO structure, or first in, first out structure. Basically, the element that goes in first comes out first, and the element that goes in last comes out last. A general representation of a queue would be like this: a container with two ends, one for enqueue operation, that is to insert elements into the queue, and the other end for dequeue operation, that is to remove the elements from the queue. The enqueue operation looks like this, where you add elements to the queue from one end, or the rear end. And we also have a overflow condition, wherein the queue is full and you cannot add any more elements to the queue. So adding elements beyond the capacity of the queue is called overflow condition, and that's basically kind of like an error. A dequeue operation would be like this, where you remove an element from the other end of the queue. And of course, we have an underflow condition, which is like an error, where there's no element left in the stack to dequeue. Now here's some examples of queues. There's just so many examples of queues, but I've taken only 2 or 3. So in real world examples, we have queue for tickets at a movie theater, which is a perfect example to explain queues. The first person to stand in line gets the ticket first, and the last person to stand in line gets the ticket last. And the elements are removed from the front of the queue, and elements are added to the queue at the end of the queue. Also, a queue of cars for paying tolls is also an example of queues. The first car to stand in line pays the toll first. The last car to stand in line pays the toll last. And of course, cars are added to the end and removed from the front after paying tolls. A good example in computer science is shared resources like printers, in which we have many computers print on the same printer. So if, for example, if we have computer A, computer B, and computer C, the first computer to send a request is the first one to get accepted. So computer A sends a request, and whatever computer A wants to print gets printed first. Then computer B sends a request, computer C sends a request, but whatever request reaches the printer first gets printed first. And of course, whatever last request gets received by the printer gets printed last. Now let's take a look at some actual code for implementing queues. Now there's lots of ways in which you can implement queues, and in lots of languages also, like C++, Java, and Python. But we're going to be implementing it in Python. But you can implement it in whichever language and whichever way you want to implement it. So we're in our Visual Studio Code, and we're going to implement our queue as a data structure in Python. Again, there's lots of ways in which you can implement queues, but I've chosen a simpler way, and you can go on to implement it in more complex ways, adding more functionality to the queue. So let's begin. So first, I've initialized a list here, which will act as a queue. Next, we have a function enqueue, which will enqueue an element or add an element to the queue. So we've taken item, and then that item is going to be our input from our user, whatever the user wants to enqueue into the queue. And this item will be appended to our queue using the append function. So basically, append adds an item to the end of the list, as it should in our queue condition. We also have a dequeue function to dequeue the element, that is, remove the element from the front of the queue. And we're going to print whatever we're dequeuing first. And of course, that's going to be at the 0th index for the first position. And after we write our print statement, we're going to delete the element using pop. And the 0 indicates that we're going to pop the item at the 0th index, the first item basically, as we always remove elements from the queue at the front end, or from the front end. Next, we have a display function, which will just basically print out our queue, which is basically a list in our case. Okay, now we're going to define a function queue, which is going to take our list, or my queue, as a parameter and act according to it. So first, we're going to ask the user what the user wants to do. So basically, we're just going to say enter 1 to enqueue, 2 to dequeue, 3 to display the queue, and 4 to exit. So whatever the user enters is going to be the argument, and we're going to get this argument and store it in this op variable, which is going to act according to the switcher. So switcher.getArgument is going to get our argument here. And while our argument doesn't equal to 4, since 4 is going to be our exit condition, we're going to continue until our argument doesn't equal to 4. So we're going to say op my queue. So op is just going to be our operation, which is basically enqueue, dequeue, or display, and perform it on my queue, which is our parameter, or our queue, or our list. And again, this is going to be the same thing. We're going to take input from the user, whatever he wants to do next. And after this function, we're going to create an empty queue and perform operations on this queue. So basically, we're going to call this queue function up here and pass our my queue as a parameter. Now let's run the function and see what we get. So as you can see, it gives me a prompt that enter 1 to enqueue, 2 to dequeue, 3 to display the queue, and 4 to exit. So first, I'm going to display our queue, which should be an empty queue. And as you can see, it is empty. Now we're going to insert an element. Let's say 3. Let's display our queue again. And we have 3 in the queue. Let's enqueue one more element. Let's say 10. Let's enqueue one more, 55. And let's display our queue now. As you can see, it has 3 at the beginning since it entered the queue first. And 55 is at the end since it entered the queue last. Now when we dequeue an element, 3 would be dequeued first since it's the first element in the line. And let's display our queue. And it displays 10 and 55 since 3 was dequeued from the queue. Let's dequeue one more. And our dequeued element is 10 now, and our queue now only contains 55. Let's try to add an element, 70. And 70 gets added to the end of the queue. So as you can see, this queue works. And here's a challenge for you. Try to implement a queue in a more complex way with added functionality. And let me know in the comment section below if you were able to do so. Thanks for watching. See you in the next video.